All right, on this problem, you see that, first of all, we want to identify any domain restrictions and solve the problem. You see it's an inequality, and anytime we have an inequality, we want to make sure that we use a sign chart. That's number one. The other thing is you always have to compare to zero when you have an inequality. So sign charts and compare to zero. That's the approach, any inequality that you have. Oops, that's zero. All right, so our first approach, we're going to look at domain restrictions. We need to do a sign chart. Anytime you do a sign chart, you need to include domain restrictions and roots. Domain restrictions and roots. So the first thing, we're going to look at this. I've got a square root there, so my domain, I got to make sure that what's under that square root, if I'm going to get a real answer, that what is under that square root is greater than or equal to 0. So 2x minus 1 greater than or equal to 0. X has got to be greater than or equal to 1/2. That's my domain restriction. This guy's got to be included in my sign chart, 1/2. All right, so the next thing is we need to go find the roots. In order to find the roots, we need to compare to 0 always. So in this particular case, this is already compared to 0. We've got everything on one side. So we want to make sure that we're looking to solve for x or isolate x. And what we can do right off the bat is just factor out an x squared. If I factor out an x squared, that means I've got 2x minus 1 on the inside, minus 4. And because we're finding roots, we're just going to deal with it like it's an inequality. The sign chart is how we deal with inequalities. To find roots, just deal with it like it's an equation. All right, so here we've got basically just zero product property here. You've got two things that are multiplied together and it's set equal to 0. So we know that one or the other has to be equal to 0. So either x squared is equal to 0 or square root of 2x minus 1 minus 4 is equal to 0. Well, we know how to solve this. We got to isolate that absolute value, or not absolute value, square root. So isolate that square root by moving that 4 over. So that's now set equal to 4. Square both sides. And when I square both sides, I'm left with something that looks like that. Go through and solve. And I end up with, I believe, 15 halves. Nope, 17 halves, sorry. X equals 17 halves. Here's one root. My other root comes from this. I never did finish it, but x equals 0 is the other root. These are my two roots. Here's my domain restriction. All of those things need to go into my sign chart. So we'll make our sign chart over here. And I would plot my 0, and then my 1/2, and my 17 halves. And this isn't drawn to scale, but we don't necessarily need it to be. We just need to know what the signs are on these things. Now for this problem, it's a little bit special in that we've got a domain restriction that says our x values better be bigger than 1/2. When they are not bigger than 1/2, they are not real. So these are imaginary or non-real values. They're not in our domain. So basically we're going to look at starting, this is strictly greater than, so our solution is not going to be on the axis, it's going to be above 1/2, so we got to look in this interval, so we need a number to plug in for this interval. Well, 1's the easiest one there, so f of 1 here, we're going to plug in 1 into our equation. We get 1 squared times the square root of 2 times 1 minus 1 minus 4 times 1 squared. And all we're interested in is the sign here. Alright, so f of 1, that's going to be 1 times the square root of 1, which is positive 1, minus 4, that ends up being negative. So my values in this interval are negative. Once we cross over this root here, so it looks like it's going to come up, and we'll test this and make sure, but it looks like it's going to come up from beneath the x-axis and cross over at 17 halves because that's a root, and it should be positive on this interval, but I gotta make sure that I check it. So I need a value on this interval right here. above 17 halves. So that looks like 9 will be the smallest number that I can plug in there. So f of 9 is going to look like 9 squared times the square root of 2 times 9 minus 1 minus 4 times 9 squared. Again, all we're worried about is the sign here. We're just worried about the sign. So this is 81 times the square root of 17. That's going to be positive. So 81 root 17, that'll be positive. This is 81, this is 4 times 81. So we don't have to find an explicit answer for this. We know that this is just above 4. And this is so just above 4 times 81, and that's positive. This is 4 times 81, so this number is going to be a little bit smaller than this number, which tells me that our values on this interval are positive, because this term right here is going to be greater than the second term. So ultimately our answers, we wanted to know when is this function greater than 0. Because it's non-real down here, we don't have any solutions here. This is negative, so we're not going to include it. So my only solutions for this particular problem are going to be on this part of the interval where we got a positive for our value. So my solutions are all the x values that are in the interval non-inclusive 17 over 2 all the way up to infinity.